Okay, so this right here is one of my favorite things I've made recently. A Mars flyby, completely built inside DaVinci Resolve Fusion. No external 3D software, no plugins, just a node editor and a bit of patience. What you are going to see is Mars drifting into frame, close and real looking, and then slowly disappearing back into space as we fly past it. And today I want to walk you through how the whole thing was built. Not a super deep technical dive, just the big ideas. What's happening, why, and how it all fits together. Let's go. So before we even open Fusion, let's think about what a Mars flyby actually needs to feel convincing. You need a planet that looks like a planet, not a flat sticker on a ball. Something with actual depth and texture to the surface. You need the right kind of lighting. In space, there's one light source, the sun, hard and directional. You need a starfield that reacts to the camera moving. And you need motion, the actual flyby, to feel smooth and cinematic. That's the checklist, and every active node in this project is solving one of those things. Alright, so everything starts with a real Mars surface texture, a 2K image of the actual Martian surface. That's all raw material. Now here is where it gets interesting. The texture doesn't just go in as a single feed. It gets split into two completely separate paths, each doing a different job. The first pass runs through a color correction node, then straight into a bump map node. What the bump map does is take the brightness information from the corrected image and convert it into actual surface depths. Bright areas become raised terrain, dark areas become craters and valleys. That's where the planet gets its physical dimension. The second pass goes through its own separate color correction, tuned differently, and feeds directly into the surface color of the material. That's what you're actually seeing when you look at the planet. The oranges, the ochres, the dusty browns. Both paths, the bump and the color, meet at the CookTorrance shader. That's the physically based material model that determines how light actually behaves on the surface. Is it shiny? Is it rough? How does it look at glancing angles? For a rocky planet, you want raw and dusty, not polished. The reason for splitting into two paths is control. You might want the bump map to have high contrast to get dramatic surface detail, while the color stays more natural. If you fed the same correction into both, you would be fighting yourself. Two paths, two separate jobs, dialed in independently. All that material gets applied to a single 3D sphere. Clean geometry, subdivided enough to hold the bump map detail nicely. Then a transform node positions and rotates it correctly in 3D space. So when the camera flies past, we are looking at the right face of Mars and the angle feels natural. That's really it for the geometry. One sphere, one transform, done. Sometimes simple is the right answer. Space lighting is one of the most important things to get right, and also one of the simplest. There's a single point light acting as the sun. One light placed way off to the side of Mars. Hard shadows enabled. That gives you those sharp, dramatic Terminator lines. The edge between the bridge side and the dark side of the planet. Then there is a very faint ambient light, barely anything, just enough to keep the shadow side from going completely black. If you pull it too high, the planet loses all its drama. Too low and you can't see anything on the dark side at all. Small tweak, big impact. Two lights, that's all you need. The stars are built with Fusion's particle system, a particle emitter throwing out a huge field of tiny blobs, some smaller, some slightly bigger. That size variation is what makes them feel real. Perfectly uniform stars look fake immediately. The region the particles live in is a large cube, and importantly, it's deep. That depth is what creates parallax when the camera moves. The nearby stars shift more than the distant ones. It's subtle, but your brain picks up on it. It makes the space feel like it actually has volume rather than being a flat backdrop. The particles get rendered separately and then composited into the final image. This is where the shot actually comes to life. The camera is a 3D camera with a 24mm lens, slightly wide. That helps with the sense of scale. It pushes you a bit closer to the subject and makes the planet feel bigger and more immersive than it would on a longer lens. The flyby itself is just one animated value, the camera's position along the z-axis. It starts far back, moves through space, passes Mars, and continues out the other side. Watch what happens on the edit page. It starts with just a sliver of Mars creeping in from the left edge of frame, that deep orange curve against black. Then the surface starts filling the screen. You see the craters, the texture, the Terminator line. Then the planet slowly drifts away. That whole emotional arc, the anticipation, the reveal, the departure, is just the camera moving in a straight line. The framing does all the storytelling. Once the 3D render is done, there are two post effects that lift the final image. First is depth of field. A depth blur node uses the Z information from the render to softly blur anything that's not at the right focal distance. It's subtle. You don't want to notice it consciously, but it adds a cinematic quality that a sharp all-over CG render just doesn't have. Then on top of that, a single soft glow pass. It catches the brightest parts of the planet and spreads a warm light around the lit edge of Mars. That's the thing that makes it stop feeling like a 3D render and start feeling like something real floating in space. Like you are actually looking at a planet lit by a distant sun. Everything then gets composited over a pure black background, deep space, and that's the final image. And that's the full Mars flyby, a real surface texture split into two parts, one color corrected for the bump map to drive surface depth, one color corrected separately to drive the surface color, both feeding into a physically based shader, one sunlight, a particle star field, an animated camera, depth of field, and a soft glow, all inside Fusion. What I love about this project is that none of it is complicated in isolation. Every piece is pretty simple. It's just about connecting the right things in the right order. If you want to try something like this yourself, start with the planet. Get that looking good first, then build the scene around it. The camera move is almost the last thing you add, but it ends up being the thing people remember most. Alright, thanks for watching. See you in the next one. One last thing, the exact settings for every node in order. Pause whenever you need to, or just take a screenshot.